Hello and welcome to lesson 15 of JavaScript. In this lesson, we're going to look at the math methods and then we're going to look at sets in JavaScript. My name is Mildred. In previous lessons, we have seen how to use methods in JavaScript. We have looked at some methods, but we want to look at the methods that we use to perform mathematical operations in JavaScript. We have a property called pi, like this, math.pi. And whenever we print math.pi to the page, we are going to get the value of pi. So let's say let x be equal to math.pi. And let's say document.getElement by ID. And we want to get the element whose ID is output1.innerHTML is equal to x. So when we print out x to the page, we should get the value of pi printed to the page. There are other math properties that we have, like if we want to have the Euler's value here, we'll put math.e like this, and it prints the value out to the page. We also have things like square root of 2 written like this, and then when we save this and refresh, we get the square root of 2. And so there are other properties of the math in JavaScript. Research them to see the properties and then see how they are used. But let's go on to look at the methods that we are going to be using in our project. We have several math methods. We are going to look at most of them. You can research to find out the use of the ones we have skipped. Basically, the usage is all with the same syntax, but you just have to know what exists so that you know when to apply them and when you need them. We have a method called math.random like this. And what this does is that it prints out a number randomly between 0 and 1. So it's always a decimal number between 0 and 1, but never 1. So 1 is exclusive, 0 is inclusive. So when I save this and I refresh my page, I'm going to have any number at random. Every time I refresh, I get a random number between 0 and 1 printed to the page. We have something called math.floor like this. And what this does is that it rounds down to the nearest integer. So when we have things like 3.44, if I refresh my page, I'm going to get 3 instead of 3.44. So it always rounds down and gives you the nearest integer for this. So if I put 3.45, it's going to round down the same. All it needs is just the integer for math.floor. We use math.random and we get only decimal numbers. In the events that we want to get an integer, we can combine math.floor and math.random like this. So we write math.random in the parentheses, math.random like this. So we'll say math.random and let's say times 20. Let's say we want to get an integer between 0 and 19. So 20 is always exclusive. So when we print out x, it will give us a random integer between 0 and 19, but never 20. If we want it to give us up to 20, all we do is to add +1 here, like this, and then it will be between 1 and 20. So we always get between 1 and 20. As long as we keep refreshing, it keeps giving us random number between 1 and 20. We have math.ceil written like this. And what we use this to do is to round up to the nearest integer. So if I have something like 3.45, it's going to round this up to the nearest integer and give me 4 instead of 3.45. If I have 3.09, it's going to round this up and I'm going to get 4. So anything above 3, it just gives you 4 to the nearest integer. If I have 3.00, we'll save, you refresh, and it will give us 3. So anything above 3 gives you the nearest integer 4. So once it's above the particular integer, even by 1 like this, it's going to round up to the nearest integer, which is 4. So once it goes above a particular point or a particular integer, it moves to the next integer. So that is how we use the ceil method. We have the math.trunc method like this, and what this does is to give us the integer part of a number. So this will just return 3 here. So when I save and I refresh, I'll have 3 because all it wants is the integer part of a number. So if I have something like 8.99, it only returns 8 to me because it gives me the integer part of a number. We have math.sign like this. And what this does is that when it is a positive integer, it returns 1. So when I refresh, I have 1. When it is a positive number, it returns 1. When it is a negative number, it returns -1. And when it is null or 0, it returns 0. So refresh, I have 0. When it is null, I'll still have 0 here printed to the page. And so that's how the sign works. We have math.min and math.max. So if I use min here, it gives me the minimum of the numbers. So let me put numbers here, 0.2, and when I have a 0, so I want to put 10 instead of 0 here. So it will give me the minimum as 0.2 on the page. If I change this to max, it gives me the maximum number here, which is going to be 10. Let's change this to 12. We'll get the maximum as what? And this to 27. So we'll get the maximum as 27 here. Refresh, and the maximum is 27. So we use this method to make our mathematical operations easier. We have the math.power like this, and what this does is it returns x raised to the power y. So let's have 2 like this, 2 and 3. So it returns 2 raised to the power of 3 like this, and 2 raised to the power of 3 is 2 times 2 times 2, which is going to give us 8. So when I refresh, I should have 8 printed to the page. So when I want to have things like 16 raised to the power of 2, I'll put 16 here and 2 here. So it's going to have 16 raised to the power of 2. If I want the square root instead of this, I'll put square root like this, SQRT, like this, and I'm going to put, like, I want the square root of 16. The square root is going to be 4. When I want the square root of 4, I will have 2 printed to the page like that. If I want to get the absolute positive value of something, so let's say 4.9, I'm doing this with square root, so I'm going to change this to ABS. When I save and refresh, the absolute value is 4.9. If I put minus, it's going to still return 4.9 because I'm getting the absolute positive value of. If I want to use things like sine and cosine, and I have a value in radian, I will do sine, and let's say we'll have a value in radian. Let's say the sine of 0. Let's bring this out to the page, and we'll have 0. If I don't want it in radian and I want it in degrees, and we know the formula for converting from radian to degrees, which is the value in degree times, we'll do maths.pi, and then we'll divide it by 180. So I think this is the formula, and so this is going to print it out in degrees rather than in radian like this. And the same thing for cos is exactly the same method. We get the cosine like this, and so you can practice this to be able to understand this. If you want to have the hyperbolic sine of x, for those who are into deep mathematics, or you want to create a scientific a page or an embedded system with some scientific calculations, you want to make a calculator, you need to understand this. So we have sine of h. This gives you the hyperbolic sine of x, or the hyperbolic sine of whatever is applied here. So let's say the value of 2 is applied here. We want to get the hyperbolic sine of this, and then when I refresh, I will get the hyperbolic sine. The same thing, we want to get the hyperbolic tangent of something, we'll do tan h like this. If we want to get the log of something, let's say we want the natural logarithm of a value. So let's say we want the log of 10. What's the natural log of 10? We're going to save this, refresh, and we're going to have the natural log of 10. If we want to have the base 10 log of a number, so let's say base 10 log of 1 million, for instance. So we're saying how many times will we multiply 10 to get 1 million? And so we know it's 10 raised to the power of 6. So the answer should be 6 when we refresh our page. There are several methods. You can research them to see the different methods. Have an index of the methods written somewhere, so that when you need to perform mathematical operations, you know what already exists that you can just call on to use, rather than recreate these in the function. We have looked at comparison operators previously. We have things like boolean, and we can write boolean like this, boolean, and in a pair of parentheses we supply an argument, and this argument is going to compare the two values. Let's say I want to know if 10 and 11 are equal. So I'll do 10 equal to 11 like this, and it's going to tell me either true or false here. So once you use a Boolean method like this, it's going to tell you compare the two with your comparison operators, and it will tell you if this is true or false. And so because it is false, it's going to return false to the page. Now we have other comparison operator. This checks for equality. This checks for equality and type. So if I put 10 equal to 10 like this, it's going to return false because it's checking for both equality and type of the value here. But if I leave this to be double equal, it's not checking for the type but just the equality of the value, and so I'll get true. So that's the difference between those two. If I put not equal to like this, it's going to check, are these not equal? It will return false because they are equal. But if I put equal to, it's going to return true because it's reversing and it's going to be the opposite. So if I want to put things like greater than or equal to, is it greater than or is it equal to this? It's going to return true because it is one of the above. Is it less than or equal to? It is not less than, but it is equal to, so I'll still get true to the page. So these are the comparison operators, so you can read them to remember them and to understand them. We also have things like logical operators. I don't think we've used them yet, but you are going to use them in your programming journey. Things like saying if, for instance, say if x is equal to 3 and double ampersand like this, and x is less than 5. So if you say if x is equal to 3 and x is less than 5, so let's say let x be equal to 4. So you are checking two conditions. It must satisfy both when you do things like this. We want to do something. We'll say let's put another condition. If x is equal to 3, or with double pipe, x is greater than 10, we want to say let y be equal to the or condition is satisfied. So I want to use this to illustrate so that when you might not make much use of this in course 1, but you might be able to use this when you want to do your front-end validation. But then in course 2, this if method in other programming languages are similar because you want to see if something from the database satisfies 2 or more conditions. You want to see if maybe all of the input field have values in them. So you want to say if everything have value, if first name and last name and all of them together are not null, then something. So this is where this will become useful. So you need to understand this concept, and then when we apply them to software development, you will understand it better. But the thing is, you have to understand that you can compare two expressions using the logical operator, the double and like this, or the double pipe like this. So you use double ampersand to say and, which means that they must satisfy both conditions. You use double pipe to satisfy either of the conditions. So let's say we have x is equal to 4. So it satisfies this condition, and it's going to say, let's print out y to the page. Here, let's make this z so that we don't print out both at once. So we say if x is equal to 4, if x is equal to 3, and x is less than 5. Now, it's going to, let's use an else statement to say y. I'll say let y here, and I'll say let z here. So you get what I'm doing. I'm trying to make sure that I use this here. So we'll say z is equal to x does not satisfy the condition. So in this situation, it is going to print out, sorry, I'm going to use y here, sorry. So in this situation, it is going to print out x does not satisfy the condition because at this point, it doesn't satisfy both. X is not equal to, so we'll use double equal sign to specify comparison between two. So x is not equal to 3 and x, but x is less than 5. It satisfies one, but not all. So it's going to give us x does not satisfy the condition. Printed to the page when I refresh, x does not satisfy the condition. But if in the event I use or here instead of and, like this, is going to change to x satisfies the condition because I say print this out if it satisfies either. So save, refresh, and it satisfies the condition. So the same thing with this z. I'm using or here, so it will say if x is equal to 3, we use double equal sign to specify comparison between both. X is equal to 3 or x is greater than 10. So either of the two. It's not going to satisfy any condition here because x is not equal to 3 and x is not greater than 10. So here is going to not print out anything to the page because we have no else statement here for this. So when I refresh, I'm not going to have anything printed because I have no else statement on the page. But if I have else here, I'll say z, so I'm redefining z twice. So I'll say else z is equal to the or condition is not satisfied, like this. Save, and this time it's going to tell me the or condition is not satisfied. So you get the logic of using logical operators. And so we are going to look at sets now. I'm going to switch over to sets.html file for us to see sets, and I'm going to change this link here to be sets.html. Now, on these sets, we have a template on the page, but I'm going to explain what this is all about. I'm going to comment this out, then I'm going to start explaining. You know, we looked at arrays previously, and we said that we can store several values in a variable, and we do that with arrays, and arrays use a pair of square brackets. We have something called sets, And the difference between set and array is that the values or the items in a set must be unique. And we declare a set in JavaScript using the set, new set keyword like this. So I'll say constant. I want to create a set of emails like this is equal to new set like this, a pair of parentheses. So I can declare it like this and begin to add items to the set, or I can declare it like this set, like in this example, and in a pair of square brackets within the parentheses of the set method, I'm going to list everything I want as a comma separated list like this. If I go with the first method, I'm going to be adding items to the set by saying things like emails.add. So I'll use the add method and I'll add a new email here, which is going to be, let's say, my email. I want to add a new email here and I'll add, let me use Hotmail, and I'm going to comment this out. So by the time I print this out to the page, I'm going to have just 2 emails. But how do we print out set to a page? We can use the for off loop that we have discussed in last week's lesson by saying for let I, which is going to be the index of emails dot values like this. You can remove the values for now and just use i.emails, and we'll try to print this out to the page. We want to print out to something called output 1. So let's print this out to output 1, and we're printing out text to the page. Now we have text, so I'm going to say let text be equal to. So now I'm doing it this way because at this point you should be able to read and understand codes on the page. If you don't know how to do it at this point, you need to go back and revise your videos and then be able to understand what the code is saying or what is going on within lines of code. You need to know how to write code, and you need to know how to edit codes. You need to know how to understand what has been done when you see a script. You need to be able to tell a story on what is going on a script by reading the code. So I'll go over it again. In JavaScript, we create a set, which is a collection of items that are unique, and we create it by writing new set. We declare it as a variable just like we do with arrays, and in the parentheses of the set method we use a square bracket and list the values that we want in the set. We can leave the parentheses empty and use the add method by calling the variable that has the set.add, and in the parentheses of the add method we add the items that we want in the set. We can use the for off loop like we used in last week's lesson. So you can revise last week's lesson to look at how we did the for off loop to loop through the values of the set, and then we can print it out to the page. So I'm going to refresh my page and I'm going to have those values of the set like that. So we have learned 2 methods of creating sets. We can also add methods by deciding to declare a variable and say, let's say let x or let person1 be equal to lovelyie@gmail.com, and then let person2 be equal to mildred@mildredgroup.com. So now when I use the add method, I'm going to be adding the variable like this, person1, and I'm going to add the variable person2. So it's exactly the same thing. Save. When I refresh, I have the same thing on the page because I have specified exactly the same thing. So if I did something like this, test1@gmail.com, and I will say test2@test.com. Refresh, and I have them on the page. So this is an alternative way of creating this on the page. So I'm going to delete this and I'm going to use this method. Now we have this set of 3 emails, and whenever we want to add a new thing to the set, we use the add method like this, and then this adds to the set. So we have test 1, 2, 3, 4 on the set. If we want to delete, let's say we want to delete test 1 out, we use email.delete, and we have this one deleted when I refresh my page like this. If we want to loop through, we use the for off loop. We can also use the for off and we put emails.values like this. It's going to do exactly the same thing. Print out what we want on the page like that. We can also use another method, which is the same thing as the values method. I say email dot, instead of dot values, we'll put dot key like this. Email dot key. Keys in plural. Email dot keys, and it's going to do exactly the same thing like that. If we want to make this compatible with maps, which we are going to look at in the next lesson, we'll use email.entries like this, and this is going to bring it out as a value pair. So it's going to put them as a map, but it's going to bring test1 at test.com twice. So let me remove this delete statement, and let's have all 4 of them, but in value pair like this. And so we use entries to list them like this in the event that we want to use this to create a map later on, because maps are in key value pairs, and we're going to look at the concept of maps in the next lesson. So this is all about sets in JavaScript. This is where we're going to end. We're going to apply this to our development projects for you to get more understanding, for you to see how they are applied in software development. Thank you, and see you in the next lesson.